Okay, we're back again testing vibration control products. This probably will be considered part 4, and I encourage you to watch the previous 3, or at least the first one for sure, before watching this one so you have more background and understanding of the test involved. Also, I'm not going to be repeating the default position, which is the piece of equipment on the floor. We already have previous videos doing that. There's no sense in doing that again. Today, and we've previously tested, if you recall, vibropods, sorbethane pucks, my own homegrown solution, which was these inside of pucks, which is to date the only thing that had a significant impact. We still have many things to go from different materials, spikes. I've got isoacoustics, which is all the rage right now to test. But today we're going to test the Auralex, brand names on here somewhere. It would be the one side. Auralex Subdudes. Now, I understand this is for subwoofers, and his main purpose is to reduce the floorborne vibrations created by the subwoofer itself into the floor. And I've got a sub. I got 2 of them actually. That's a Vandersteen sub back there. I'll do a test on that eventually. So, hold your horses on being too critical of this test. I'm just using this as another different type of mechanism for stopping vibrations. Basically, it's just foam with a wood top, MDF type top that's covered with a felt. So theoretically, just intuitively, you think it's something that would be pretty good for vibrations. Certainly for the scale of subwoofers, you can see why this might be a viable solution. But let's just see how it works on a piece of equipment with the drop tests we've been doing to kind of get a gauge of if it makes a meaningful difference one way or the other. So let me move this piece of equipment on there and then we'll do the test. Okay. We're on the platform now, and again, like we've done in previous videos, 4-pound weight from approximately the height of the top of the case, and I'm going to try to catch the bounce to prevent it from bouncing so we can just get the initial impulse and the ringing and not bouncing. Again, if you did watch the other videos, this is duplicative. I apologize, but just in case you didn't, X, Y, and Z axis, very sensitive to touches. X is left and right, Y is north, south, Z is up and down. As I push on the case, you can see the Z. Very sensitive. So let's see what happens when we drop the 4-pound weight. That actually hit the actual stand, so ignore that one. Okay, that's a fair sample. And again, as I've said in previous videos, this is a primitive test. It's very hard, even dropping relatively the same each time. You can see on the video, on the register, it registers wide fluctuations per drop on the same shelf. But what we're looking for is big deltas between what is being shown here when we drop it and when we did it on the carpet. And again, if you saw the other videos, you'll know that what we just saw was approximately the same thing that we were seeing with the same piece of equipment on the floor with no vibration control. Maybe a little bit less ringing, but I'd have to look at the video in slow motion and judge. But again, nothing that has compared yet to the solution I presented in one of those videos, which was my homegrown solution, which was using squash balls, soft squash balls, double yellows. Now, I understand Ginkgo Acoustics does balls, and so they deserve credit. I haven't tested their stuff. I've seen videos. there are a couple things that I'm a little questionable about. They're talking about using hard balls and then them wearing out over time. I'm purposely using the softest. I want to create a total suspension. And again, this is not, I'm not taking credit for this other than coming up with a basically a cheaper solution than any of these. The person that really deserves credit that got me started on this was Max Townshend, because I got his fairly expensive, actually really expensive, bars that worked on my speakers. And my speakers, it's suspended, it moves. And you would think that that's crazy, but it's not. And, well, heck, let's do it right now. I also test different damping material. I do it on the outside before I put it on the inside of the speaker, so that's what you're seeing there. But I'm stomping my foot on the ground, and you're seeing no impulse response whatsoever, just a light impact when I stomp. Let's just put it on my center channel speaker that isn't on. Okay, so again, credit to Max Townshend for creating something that inspired me to find a cheaper solution that approximates what he's able to accomplish with those seismic bars. If you can afford them, I would go with those. But to date, nothing has beat my homegrown solution that approximates it. And we're going to still test, though. We've got spikes to come. We've got slate material. We've got isoacoustic scales. Let's show you those again if you didn't see the previous videos. Those are all the rage right now. I've got them. We can test them. In future videos, you're going to want to subscribe. You're going to want to see these power cords. This was the original power cord that started, well, I wouldn't say it's the one that started all, but it came with a 100-page instruction manual. You're going to want to watch that video when I come out with that. In any case, hope you enjoyed this video. Subscribe, get notifications if you've enjoyed it, and leave me some comments. Thanks.